Okay, so same line, y equals 3x plus 2, but this time we're going to reflect it across the line y equals x. So I could take my points and just reflect them individually across the line y equals x, which would give me, reflect them individually across the line y equals x, interchange the x and y coordinates to get my new points as 2, 0, 5, 1, -1, -1, so that one actually stays put. Then I could use those points to find the slope of the new line, which is positive 1/3. And so then, once I find the slope, I can then plug a point in for x and y into point slope form. So y minus y1 equals the slope times x minus x1. And if I just isolate y, distribute that 1/3, I end up with the equation of the line being y equals 1/3 x minus 2/3. So if you think about how did we get from the old points to the new points, we just interchanged our x and y coordinates. So if I'm thinking about the equation, if I just want to reflect this line across the line y equals x, I can just interchange x and y. I'm going to switch x and y. They're going to switch places. This is something that's going to come up later in Algebra 2. It's called finding the inverse of an equation, but don't worry about that. That will come up later. But we're just going to interchange x and y. I'm going to put x in the y spot and y in the x spot. So x equals 3y plus 2. If I'm reflecting across the line y equals x, I'm just switching x with y. And so now what I can do is I can solve for y. I want to isolate y. So I'm going to subtract 2 from both sides. So I have x minus 2 equals 3y. And then I'm just going to divide by 3. So y equals x minus 2 over 3 is totally fine, totally simplified. Or I can think of those as like, this is 1x over 3, so that's 1/3 x. And then minus 2 over 3. So I got the same equation that I got by individually reflecting the points. So even if you had left your answer in this form, that would be totally fine because that's fully simplified. A-okay, just harder to graph because it's not in y equals mx plus b slope-intercept form. So if we think, like, what is this visually going to look like? If we're reflecting across the line y equals x, remember that has a y-intercept of 0 and a slope of 1. So this orange line is the line y equals x. So if I'm going to reflect this pink line across this orange line, my new y-intercept is negative 2/3, which is like right here. And then my slope is up 1 over 3. Up 1 over 3. So this is just sort of like a guess, but here's the blue line. So if you think, like, we are taking that pink line and reflecting it over the orange line, taking that pink line and reflecting it over the orange line, the blue line and the pink line look like they're like mirror images of each other across that orange line y equals x.